Okay, welcome back. Today I'm going to do a very short bit here. We're going to cover how to do local stack and memcopy in 8080 assembly for my terminal project. In terms of opening files and stuff, I figured out how to open files, but copying the file name to the file control block is a little bit more difficult, so I'll have to work on that and I'll get back to you on that one. Anyway, let me boot up the Altair and let's get right into it. So let's see. Okay, we are in. Let's launch WordStar. And while we're waiting, let's get some good stuff here. Yeah, it should be good. Okay. Anything interesting with this? Nothing crazy today. Let's see. Nothing crazy today. I'm going to show you how to do local stack, why you want to do local stack, and then I'm going to show you how to copy the arguments you pass into the program from the command line, how to copy those into local memory space. You want to do that because, well, just so you have them. Okay, so first things here, we're going to want to put in a new define. We're going to call this buff EQU. This is going to equal 80H. What buff is, it's the location of memory in which your arguments that you type in get passed to. So for instance, if I did terminal /P1 for like port 1 or something, then the characters /P1 will get copied to location 80H along with the number of characters I've typed, 3. So we're going to copy those over. But first, let us make a local stack. Making a local stack is extremely easy. So what we're going to do is first we want to zero out the HL register, LXI H0, 0 out HL. Actually, let us do this. Set up local stack. And then I want to DAD SP. So this basically moves stack pointer to HL. And then once you do that, I want to store HL, SHLD, store HL double to a variable space. We're going to call it old SP. So store HL to old SP. And then once we do that, we're going to load the new stack location to the stack pointer, LXI SP. I'm going to stack top, load local stack to SP, and that's it. So that right there is local stack, and let us go all the way down to the bottom here to make these variables. Okay, so we're all the way here at the bottom. We're going to add 2 new variables. We're going to do old SP. DS, I'm going to do 2 because it's going to be a 2-byte variable space, because HL is 2 bytes, and that's the maximum amount of memory we can directly address. Then we're going to make the new stack. So we're going to do DS data store. I'm going to make it 64 bytes deep, so for 16 double words. And what you do here is the stack actually goes down. So stack starts at a higher point in memory and then goes down. So you don't want to put the label in the front, because if you put the label in the front, like here, then you get weird things happening. Actually, what starts happening is the stack starts going back down your program and starts overwriting your stuff. So you want to put the label after the space declaration. So stack top, like that. And make sure you have your new line. Okay, so now that we have the variable set up, the stack top and the old stack pointer, we have to set it up so that when you exit the program, exit the terminal, the stack gets restored. The stack pointer gets restored to where it started in the beginning. This isn't 100% necessary because CPM will save your stack pointer for you. But because we have a very deep uninitiated stack, weird things can happen. So it's good practice to clean it up. So let's go up to our exit function. Okay, and we're going to load HL double with old SP. So load HL with old SP. And then we're going to do then we're going to do a stack pointer HL swap, and that should be good. Swap HL with SP. Looks good. Let's control save. Quit. And quit for real. Let's assemble. Term. A load YATERM. Looks good. YATERM. Let's run it. Oh, there, I already am running it. 200 looks good, guys. It's all there. Felt send hello to txt. That's all still there. Let's quit. Looks fine. Nothing weird happened. Now let's go in and add a memcopy so that we can copy all the arguments you pass in to local storage. Jaeger's good stuff, man. So remember that variable we made that defined buff? So buff, again, I'll tell you, that's where all the arguments that you type in to like terminal /b 480 or whatever your baud rate is going to be, right? So those arguments are going to be passed in to ADH, but not just those arguments. The first, let me show you. Looking at the CPM interface guide, if you go to page 7, it shows you exactly what gets passed in to ADH. Actually, it's the number of characters you've typed, plus a space, and then all the characters you've typed. So the number of characters you typed is actually 2 plus what you physically typed. So just keep in mind. But that's okay because we want to copy the entire buffer, so we don't have to worry about manipulating that first byte there. So you want to do all of them, which means CPM has a limit of 128 bytes that you can pass into a program, but that's well beyond anything that anyone would feasibly do, for CPM at least. I know this makefiles can get pretty long, but let's see how we can do this in CPM. It's very easy, and I'll show you right now. Okay, so once we get in, first thing you want to do, so I want to do it right after I set up the stack, the local stack. So let's make a spot here, and let's start moving. So let's do this, copy arguments to local space. It's very easy. So we're going to do lxih buff. So this is going to be load HL with buff location. And then what we want to do is we want to get the number of bytes that you have typed in as an argument. And remember, HL, which is a double register, can also be accessed as M, and M holds the contents of HL. So you can load it indirectly from HL, or you can use M. So whatever you want to do, I'm just going to use M. It's very easy to do. So we're going to do move destination, A, want to move to the accumulator, M. And the reason actually, scratch that. We're going to load directly to C. I loaded to A before because I thought I had to like change some stuff, but we don't have to change anything. So load contents of HL to C. And now here we're going to do our MEMCPY. So begin MEMCPY. Okay, so this is important. So BC holds number of bytes to copy. Then LXI dbuff. DE holds source address. LXI H. We're going to call it args. HL holds target address. Okay, and then we're going to call MEMCPY. So if you know MEMCPY from C, you have source, what is it? Yes, not memset. That's different. MEMCPY is source, target, and length of bytes. This is why it's literally this easy, and you pass it directly into this function. So MEMCPY is really about as fast as you can get. Looks good. Let's go down and make our MEMCPY function. Okay, we're right below the exit function, MEMCPY. This routine I copied straight off from the Wikipedia site for the Intel 8080. It's really awesome because Wikipedia for like the Z80, the 8080, I think maybe the 6502, maybe 6800, and a few other CPUs, they have like an example assembly routine for MEMCPY to show you what the instruction sets do. It's so awesome. So I'm just going to use this one. Very hard to mess with perfection. So let's go. Move A, B. We'll just put this MEMCPY routine from Wikipedia. Or a C, this basically, or a C checks to if BC is 0, and RZ done if 0, right? And then here's the loop, MC loop, because we already have a function called loop, don't want to call it twice. Let's do this. What is it? LDAX, load immediate, no. Load, hang on. Yes. LDAX, that's right, load indirect. So load source byte to A. Then move A to target, load byte to target, and then we want to increment both. Increment D, increment source address, increment HL, increment target address. I told you it's really easy to do this stuff. And then you want to do DCX, B, you want to decrement byte counter. And then all you got to do is move BA, right. Get ready for compare. So this is actually somewhat of a clever way, because here we're going to do this. Well, watch this, or A. We're going to or A with C. So what happens is as BC goes down, remember or returns 1 if either A or B is true. So if you or one byte with another byte and there's a 1 anywhere, which means that it's not quite 0 yet, you're going to get a 1. So if you get a 0, that means nothing's there. So that means the high byte is 0 and the low byte is 0 for BC, which is counter, which means BC is 0, which means you're done. It's a somewhat clever way of doing it. Check to see if byte counter is 0. And JNZ MC loop, if not 0, loop, and of course if it is 0, return. And of course we are not quite done yet. We have to make a variable. We're going to call this args. So this is going to be DS, and we're going to do 32 bytes. We don't need that much more. So let's escape. Sorry. Forget which text editor I'm using. Okay. Quit. Let's try assembling it. That failed. A load ASM. That failed. A load YATERM. This whole terminal still isn't even 255 bytes. That's insane. Term. Oh, yep, that's running. M200. Looks good. That's it. You don't see anything because nothing we did affects the screen, except if you did the stack pointer without returning it. Then you'll see weird things at the end. Here, let's do control. Yep, control X works. Okay, so that's it. Next time, I'll show you how to open the files that you actually type in. If you do YATERM, right, and you do something like control S, I want to send a file. I want to send, say I want to send the resident assembler editor, RAE1.ptp for paper tape, and hit enter. Then I want to be able to send. I want to be able to send that file. I'm able to open files in CPM from the command line, not from, I still have to figure out how to do a MEMCPY over with some formatting. I'll get into it later. It's a little more involved, but it's very easy. I read the manual, so you guys don't have to. And if you guys stick with me through the series, you'll be up and running with 8080 assembly on the CPM, making your own terminals, doing your own things with them, crazy stuff, making your own games, whatever. So I'll read through it. I'll show you how to do the certain things in assembly, because there really isn't that much in terms of help forms in 8080 assembly. So I'm doing it for you guys and for me. See you next time.